Hi, this is Lauren, and the problem I'm going to be doing is number 15. A ball is tossed from an upper story window of a building. The ball is given an initial velocity of 8 meters per second at an angle of 20 degrees below the horizontal. It strikes the ground 3 seconds later. A, how far horizontally from the base of the building does the ball strike the ground? B, find the height from which the ball is thrown. And C, how long does it take the ball to reach a point 10 meters below the level of launching? So the first thing I did is I drew a diagram. This is the building. I'm going to have up in the X and Y direction be just a regular Cartesian graph. Then I have the horizontal is here and it is thrown 20 degrees below, so it is thrown over here. This kind of angle at 8 meters per second. And it's thrown and then it'll follow just a regular projectile motion, kind of free falling until 3 seconds later when it'll hit the ground. So A asks for this distance, B asks for this distance, and then C is where is it when it's 10 meters from its initial launching point. So the first thing that I did was I separated out the velocity in the X and Y direction. So if you just do cosine 20 degrees times 8 meters per second, in the X direction, it's 7.2 meters per second. That's how much it's traveling in the horizontal direction. And in the Y direction, it's just the sine of it. It's 2.74 meters per second in the downward direction. So A, the first thing it asks you is just how far this is. We know its velocity going this way. It's constant because there's no acceleration, so that's 7.2 meters per second, 7.52 meters per second, and it lasts 3 seconds. So we know that it's just velocity times time equals, the seconds cancel out, and you just get the displacement, which is 22.56 meters horizontally from the base of the building. That's A. Now for B, we have to do a little bit of kinematics. So it asks, what is the height of this building? So we know that the initial velocity when it's thrown is negative 2.74 meters per second because it's thrown down. We know the acceleration of any free fall is negative 9.8 meters per second squared, and they already give us the time, which is 3 seconds. So if I want to find the displacement, I'm just solving for this delta x. So I use the equation VIT plus 1/2 AT squared. I just plugged in all my variables, and at the end, make sure though that you heed the minuses or the negatives because the direction of velocity initially is the same sign as your acceleration. So just make sure that's A-okay. And then in the end, you get 52.32 meters tall. That's the height of the building. So finally, let's go to C. C asks, what is the time when the ball is 10 meters from its original launching point? So we know VI is negative 2.74 meters per second because this is just in the Y direction. A, of course, acceleration is always negative 9.8 meters per second squared because there's nothing affecting it besides gravity. And then delta x is just the change in displacement, and since I want it 10 meters from its initial launch point, and then it's just 10 meters. So if you wanted to use this other kinematic that we did, you would have to do quadratics, and I wasn't really down, so I solved for VF first. So I did VF squared equals VI squared plus 2A delta x. And then if you just plug in your variables, again, heeding the negative signs, you get VF is negative 14.27 meters per second. That just means that when it is at 10 meters, it is going down at this velocity. So then after that, I'm just now solving for time because that's what the question asks. So VF equals VI plus AT, negative 14.27 meters per second equals negative 2.74 meters per second minus 9.8 meters per second squared times time. If you add this to this side and you divide it by negative 9.8 meters per second, you get time is 1.18 seconds until 10 meters below the launch level.